Good morning! I'm Dr. Huang. Today is another wonderful day to learn some new tricks together. We will learn how to use the method of initial rates to find the rate law of a chemical reaction. To use the method of initial rates to find the rate law of the reaction, you need to be provided a balanced chemical equation, a series of concentrations of all reactants. There are two reactants for this particular reaction. We are provided a series of concentrations of reactant 1. We are also provided a series of concentrations of reactant 2. The parentheses here and the parentheses here represent the concentrations of the corresponding chemicals. We are also provided the initial rates of the reaction at different concentrations of the reactants. If these data are not provided to you in the form of a table, you need to organize the information in the form of a table similar to this one. It will be easier for you to find the rate law of the reaction. There is a standard procedure for this method. The first step is to write down the general form of the rate law. The general form of the rate law of any chemical reaction always starts with rate equal to K multiply. Then we will put down all the reactants. We also put down a parenthesis for each reactant. The parenthesis represents the concentration. We will put down an exponent for each reactant. You can use X, Y. You can also use the Greek letters, alpha or beta. The second step is to plug all the concentrations of the reactants and the initial rates of the reaction into the general form of the rate law. Since we have 3 experiments, we will get 3 equations. This is the rate of the reaction of the experiment 1. And we will use the concentration of the first reactant and the concentration of the second reactant from experiment 1. Mathematically, you do not need a parenthesis for 0.10 to the x power. Remember, the parenthesis represents the concentration of the chemical. A number doesn't need a parenthesis. We will use the data from experiment 2 and experiment 3 to get 2 more equations. Make sure you double-check your equations. Do not copy down the wrong numbers. Next, we are trying to use the mathematical skills to find x, y, and k. If we look at equation 1 and 3, we find that on the right side of the equation, k and k are the same. 0.10 to the x power, 0.10 to the x power are the same. The only difference is the third term, 0.20 to the y power, and for equation 3 is 0.10 to the y power. If we use equation 1 divided by equation 3, k and k will cancel, the x term and the x term will cancel, we only have the y term left. Theoretically, we can calculate the value of y because we only have one variable. Let's do this. This is step 3. When we use equation 1 divided by equation 3, what we mean is we use the left side of equation 1 divided by the left side of equation 3, and we use the right side of equation 1 divided by the right side of equation 3. We can punch these 2 numbers into calculator. We will get 2. On the right side, k and k will cancel. The x term and x term will cancel. What we have left is 0.20 to the y power, 0.10 to the y power. Remember, a to the c power divided by b to the c power. This is equal to a divided by b to the c power. And then what we have on the right of this equation is 0.20 divided by 0.10 to the y power. we copy down what we have on the left. We punch these two numbers into a calculator, we get this is equal to 2. So 2 to the y power. We copy down what we have on the left. We take the natural log for both sides. Natural log 2 on the left and natural log 2 to the y power on the right. Remember, natural log b to the c power equal to c multiply natural log b. If we use this relationship, this will become y multiply log 2. We copy down what we have on the left. This will cancel, so we get 1 equal to y. We normally write down y equal to 1. Next, we can plug the y into equation 1 and 2. But if you want, you can also plug the value of y into equation 2 and 3. If we want to use equation 1 and 2, we can say that if we use the same mathematical operation, we can cancel k. Although we cannot cancel the y term, but if we know the value of y, it will become a number. We only have one variable left. Mathematically, we can solve this equation to find x. Here is the work. Step 4. Because we already know that y equal to 1, so this will become 0.20 to the first power. Y equal to 1, so this is 0.40 to the first power. K and K will cancel. A multiply B divided by C multiply D. This is equal to A divided by C multiply B divided by D. On the left side, we punch these two numbers into a calculator, we get 0.125. On the right side, it will become 0.10 to the x power, 0.20 to the x power, multiply 0.20 to the first power, 0.40 to the first power. We can punch these two numbers into a calculator, and this will become equal to 0.5. So this will turn into 0.125 equal to, remember what we did for this one? Here, this is equal to 0.10 divided by 0.20 to the x power. This is 0.5. We can divide both sides by 0.5. We will get. From a calculator, this is equal to 0.0625. And this is equal to 0.5. Okay, we can use the same method here to find the value of x and x equal to 2. After we find the value of x and the value of y, we can plug them into these three equations. You can choose any of them. We will choose equation 1. Let's call this step 5. Then we can solve this equation to find the value of k. And it is equal to 1.23. And the unit is 1 divided by molarity to the second power and second. If you do not know how to get the unit of this k, you can watch my other videos. Our answer for the Reed law of the reaction is, it is the first power for hydrogen. You can omit that because mathematically they are the same. Let's look at part B. Part B asks us to calculate the rate of production of water. And we are provided the concentration of nitrogen monoxide and hydrogen gas. If we use the equation we get from part A, we can calculate the rate, and this rate is the rate of reaction. Remember, we learned another relationship between the rate of reaction and the rate of production, and also the rate of consumption if you need, by the balanced chemical equation. This problem is doable. Let me show you the detailed steps. And this is the rate of reaction. It is not the rate of production of water. Let's use the relationship we learned earlier. And we should divide by the coefficient of water, which is 2. We all got the rate of reaction. It is too much writing. Let's call this x. And x equal 2. We're done.